Okay, now let's look at question 5. This requires a real understanding of the function and the inverse function here. So we're given these different functions, they're represented in different forms. We have the f of x, the graph of it. We have g of x represented by a set of points and h of x by an equation. So it's asking us to find the inverse of g of -1. So what you need to think about, we'll go to the g function. So what you need to, this is the original function, not the inverse function. And remember, because you swap the x's and y's, because this for the inverse that represents the x, but for the original function that would represent the y. So we need to find -1 in our y's for the original function. And we can see here, there is -1. So therefore, for the original function, when y is -1, the x value is 0. So therefore, for the inverse, when the x is -1, the y value would be 0. So you just remember, you're always swapping your x and y coordinates. Similarly then for the next one, we want the inverse of function f, but at 0. So remember, this is the graph over here of the original function. So on the original function, that would be when x is 0 for the original function. When y is 0 on the original function. So on the original function, there is when y is 0. And so therefore I can see that x is -1. Okay. So on the original, so for f of x, what it's saying is we have the point -1. Oh, sorry. Shouldn't put an equal sign there. Let's get rid of that. Okay, let's try again. So for f of x, we have the point -1, 0. But for the inverse of f of x, we have the point 0, -1. Okay, so you can see when it's asking for the inverse of of 0, then the y coordinate is -1, just the opposite to the original. So then again, same idea, the inverse of function f of 3. So we actually want when y is 3. So I can see there on the f of x function, when y is 3, x is 2. So remember, on the original we have the point 2, 3, but on the inverse function it would be the point 3, 2. So hence the 2. For inverse of h of -3, okay, that's a bit trickier. We have to do a little bit of work this time, because you need to work out what we're going to get. So remember, this is like the -3 here is the y coordinate of the original function. So we would have -3 equals x minus 2, because we need to find out which x coordinate it is. So just solve that, and we can see add 2 to both sides, and we get x equals -1. So the answer is just -1. Now it's getting trickier. So we're doing some composite functions here. So you need to find what inverse g of 2 is. So we go to our g function. Remember, this is actually in the original function, it's the y coordinate in the original. So where is it 2? We can see there it's 2. So that's the same as saying we want to find f of, so inverse g of 2 is 1. So we want f of 1. Now we go to the f function. So now we're just doing normal function, not inverse. So when x is 1, I can see on the graph y is 2. So that is, the answer is 2. Okay, this is similar. So I want to work out what the inverse of the function of 0 is. So remember, this is the y coordinate on the original function. So let's go to f function. When is it 0? Oh, I can see it's 0. Oops, sorry, I've done it wrong again, haven't I? Sorry, we've already got the answer here. We can see here the answer is -1. When y is 0, x is minus 1. So we're finding g of minus 1. And then it's easy because we go up here. So now we're just talking about the normal function, the original function g of x. And then we look, when is it minus 1? And we can see there g of minus 1 is 5. And so our answer is 5. Okay, so hopefully that has cleared up some problems for you. And it's given you then a bigger variety of types of questions that you could be asked with the inverse function. Good luck.